Hello, today we are starting chapter 10, which is all about circles. A circle in geometry is defined as a group of points that are equidistant from a given point, meaning the same distance away from one certain point. That point is called the center of the circle. The center of the circle is always used to name a circle. A circle gets named like this. This is the symbol for a circle. Looks kind of like a donut. So in the first picture here, we can see circle C. Its center is always indicated by a point, which I've kind of enlarged here. But if there's a dot in what appears to be the center of the circle, you can assume that that point is in fact smack dab in the center. So this is circle C. Inside of circle C are lots of different parts. The first one is called a chord. A chord is a line segment whose starting and stopping points, the endpoints, are on the circle itself. In this first picture, we see two different chords. One is line segment EF, and the other is line segment DA. Both endpoints are on the actual circle itself. I'm sure you're all familiar with a radius. A radius is a line segment whose one endpoint is on the circle and the other endpoint is the center of the circle. The plural of radius is radii. Circle C has three different radii drawn. One is CB. There's also CA and CD. Of course, we know that all radii of a circle are the same exact size, so all three of those line segments are congruent. And then if we put two radii together, we create something called the diameter. A diameter is a special type of chord because it starts and stops on the circle itself that runs through the center of the circle. This picture has only one diameter. Here, the diameter shown is DA. As I said, the diameter is always twice the length of the radius, where in other words, the radius is half the length of the diameter of the circle. One of the other things we'll look at is the circumference of a circle. So you should know this formula already, but if you don't, there are two different formats for the exact same thing. Circumference of a circle is kind of like the perimeter of any other shape. It tells us the distance around the outside of the circle. The distance around the outside can be calculated as pi times the diameter, or 2 pi r. Since twice the radius is the same thing as diameter, these two formulas mean the same thing. They're just two different ways to write it. So using that information, let's look at a couple of examples. The second picture goes with questions 1 through 7. So number 1, name the circle. So circle's always named according to its center. Here we see that is point E. So this is circle E. Then name a radius. There are lots of them in this picture, 4 to be exact. It says name a radius, so you only need one, but I'll show you all 4 are EA, EB, EC, and ED. Question number 3, name a chord. So a chord starts and stops on the circle. There are 3 of them in this picture. One is AB, another chord AC, and the last one BD. Of those chords, 2 of them are diameters because 2 go across the circle and cut through the center. They are AC and BD. Question number 5 says, suppose that line segment BD is 12 millimeters. So that was the diameter of the circle. Find the radius. So radius is always half of the diameter. So if I take the diameter, cut it by 2, the radius will be 6 millimeters. Question number 6 says, suppose that the length of CE is 5.2 inches. So CE is a radius. Find the circumference of the circle. So let's use the formula circumference equals 2 pi r. So we have 2 pi times the radius here, 5.2. When you type that into your calculator, please use the pi button. It gives you the most accurate answer. We're going to do that throughout this chapter. So when I type in 2 times pi times 5.2, the circumference is about 32.7, and this one is measured in inches. In question number 7, it says, suppose that the circumference of the circle is 2,368 feet. How long is the diameter? So this time I'm going to use the circumference formula, pi times diameter. I know the circumference, so I'm going to plug that in for C. 2,368 equals pi d. To get the diameter by itself, divide both sides by pi. And if we round to the nearest tenth again, we see that the diameter is 753.8, and this is in feet. When you flip over to the back of the notes, you'll see the next set of questions is also an application of the radius and diameter of a circle and their relationship. In question number 8 through 13, we have several circles built inside of each other. It says circles G, J, and K all intersect at a common point L. So just by reading that, we know the center of each of these circles, G, J, and K. That will help us identify diameters and radii. Then it says the length of GH is 10 units, and we have to find a bunch of measures. Before I answer the actual questions, I'm going to label everything I know on the picture. So if GH is 10 units long, and it's a radius of circle G, then all of the radii must be 10 units long. All of the radii for circle G. Okay, here there are 4 of them. Now if I consider GL, one of the radii of the big circle, if that's 10 units long, GL is also the diameter of circle J. So if circle J has a diameter of 10 units, its radius, half of that, must be 5 units. So JG is 5, and JL is 5. But then JL is now the diameter of the smallest circle, K. So if circle K has a diameter of 5, its radius, half of that, would be 2.5. So KL, one of the radii, and JK, the other one, is 2.5 units. Now we can take what we marked on our picture and answer the actual questions. So FG we marked as 10 units long. FH is the diameter of the biggest circle. So if the radius is 10, diameter is double that, or 20. GL was another radius of the biggest circle. That's also 10 units. GJ we marked as 5. JL was 5 as well. And the last one, JK, we marked on our picture as 2.5. Okay, for questions 13, 14, and 15, it says circle W has a radius of 4 units. Circle Z has a radius of 7, and the length of XY is 2 units. So circle W, so W is the center of the circle that's on the left, the smaller circle, and that circle has a radius of 4 units. So W to I has to be 4 units, and from W to the other end of the circle, so Y here, must also be 4 units. Circle Z, so Z is the center of the large circle, has a radius of 7 units. So Z to C must be 7, and Z to X, which is right here, must also be 7 units. Then it also tells us that XY is 2 units long. So in the picture, I know that WY is 4 units, but XY, part of that is 2. So the other piece, WX, must also be 2. Then since XZ is 7 units long, but XY, one piece of that is 2 units, the rest of it, YZ, must be 5 units. I believe that answers all of the questions. So question number 13 said find the length of YZ. We just said that's 5 units long. IX, so from I over to X, has 2 different parts. One is 4, and the other is 2 units. So I to X should be 6. And IC is the entire way across the picture. Be careful with this one. You don't want to add up every single number we put on the picture because part of it is overlapping. So if I were to consider IX, we just said was 6 units. And then from X over to the other side, C. So that's the diameter of the big circle. That should be 14. I did 7 times 2. So 14 and the 6, the entire way across this picture should be 20. There are a few other vocab terms for this section. One is for congruent circles. Congruent, of course, means exactly the same size and shape. Congruent circles have to have the same length of radius. And then we also have a term called concentric circles. Concentric circles have the same center, but different radii. The picture on the right here shows you a pair of concentric circles. Here there are 2 different circles, but they both have the same center A. Notice that the smaller circles fit perfectly inside of the bigger one. Concentric circles are what occur when you do something like you throw a rock into a lake. When the rock hits the water, it creates those kind of ripples out from there. Those are called concentric circles. And then the last 2 terms sort of go hand in hand as well. An inscribed polygon and a circumscribed polygon. An inscribed polygon fits inside of another shape so that each of its vertices lie on the outside shape. Here we have a quadrilateral, ABCD, that's inscribed in a circle. So the whole polygon's inside of the circle, but its vertices lie on the circle. The circle, circle E, is said to be circumscribed, so around the outside of the polygon, but again, it contains each of the vertices. Those terms will help us answer the last question. It says, find the exact circumference of a circle if an inscribed right triangle has legs that are 7 meters long and 3 meters long. So I have a picture here down at the bottom. If I know the lengths of the two legs of this right triangle, we can use Pythagorean theorem, of course, to find the length of the last side. If I plug these into Pythagorean theorem, 7 squared plus 3 squared equals the hypotenuse squared. So 7 squared is 49, 3 squared is 9. 49 and 9 is 58. Since it said the exact circumference, I'm going to leave this as the square root of 58 equals x. X, the hypotenuse of this right triangle, has to be the diameter of our circle. So once I've found x, I now know that this is the diameter. So I can use it to calculate the circumference of the circle. So circumference is pi times the diameter. Here we have pi times the diameter was a square root of 58. This is the exact circumference. You would not want to type this into a calculator, then you'd be getting an approximation. So you can leave your answer just like this. And this should be in meters. Please make sure you complete tonight's homework. Have a great day.